Okay, continuing our quadratic solving review. A couple days ago we were focusing on zero product property and factoring, and before that we were even doing solving using square roots when there's no b term. But remember, all of those things that we did the other day when it involved quadratic solving, we could have used quadratic formula. And but again, it's long-winded. We don't want to use it unless we have to. A reminder, remember, the quadratic formula is x equals, whoops, not too sure what happened there. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. And this was the last thing we were working on before we left for remote learning. And we've touched on it here a couple of times over the last week or two as well. We use that to find, again, the solutions, which is the same thing as the x-intercepts of any parabola. So here we're asked to use quadratic formula. This one here, you could maybe try to factor it. Turns out it doesn't factor. It wouldn't be hard to try to factor because those n numbers are prime. But before you use the quadratic formula, folks, you first want to be set equal to 0, which we are here. And then write down your a, b, and c. Remember, a is in front of the x squared, b is in front of the x, c is the constant. Now we're just plugging in. Opposite of b, of course, is positive 14, plus or minus square root. Don't forget to use parentheses here. B squared minus 4 times a times c. Now, actually, let me finish this. This is over 2 times a. If you recall, so that denominator ends up being 6. I had you use your Inspire calculator. It's a little bit easier. And if you want to take out your iPad and use that now, that's fine. I asked you to plug in what was underneath the square root sign exactly. Not the square root itself, but just what's underneath it. Make sure you have the parentheses. And this negative 14 squared minus 4 times 3 times 2, if you plug that in correctly on your iPad, it should come out to 172. Now that is not a perfect square, okay? That is not a perfect square. So now in the next step, we're just going to use our calculator. The iPad's fine. We're going to do 14 plus the square root of 172 over 6. If you recall on your iPad, the easiest thing to do is to first hit that fraction button. Hit the fraction button and type in the stuff on the top, and then over 6, and this comes out to 4.52. But now you want to do the same thing with subtraction. Remember, we had this plus or minus, and here you're going to get 0.15. So those are our two x-intercepts. That's where the parabola would cross the x-axis if we were to graph this. Okay. Remember, these are actual coordinates. This is actually 0.15 comma 0. This is 4.52 comma 0. All right. And there we go. You guys were doing a nice job with this, if I remember correctly. If you want to, well, we'll do one more together here, and then you can do the next two yourself, maybe. This one here only has one additional step. You want to be equal to 0. So I want to take these things and I want to move these things over. I like moving it all to the side where the x squared is positive. I think it's a good habit to get into. Now we can write down our a, b, that's an equal sign, sorry, c. So x equals opposite b plus or minus square root b squared minus 4 times a times c all over 2 times a. So I got 4 down there. Now again, punch this in exactly as it's written with the parentheses on your iPad and your Inspire, not with the square root though, and this comes out to 57. That's a number a lot of teachers like to see. They want to make sure you're doing that part correctly. Sorry, my negative sign should be there. I don't know if I forgot to write it. And now, of course, we're going to do the same thing that we did before. We're going to do this twice. We're going to do it once with -7 plus that. We're going to do once with -7 minus that, and both of them over 4. And you should get 2 answers. Okay, easiest to use your Inspire and use the fraction button. If you don't have an Inspire handy, what you want to do is you want to figure out the top part first. Okay, once you figure out the numerator, then take that and divide it by 4. All right, you guys can try the next 2. Remember, make sure you're equal to 0. I'm going to do them both here, but if you want to try them yourself, you can. So this would be 3x squared minus 20x plus 8 equals 0. So A is, sorry, my A is just kind of, A is 3, B is -20, C is 8, X equals opposite of B plus or minus square root of B squared minus 4 times A times C all over 2 times 3. So my denominator becomes 6. And if I type in everything correctly underneath that square root sign, I'm going to get 304, which is not a perfect square, which means that these things wouldn't have factored anyway. If this number is not a perfect square, it would not have factored. Okay? So just do the same, do this twice, once with the adding, once with the subtracting. And our x-intercepts are going to be 6.24 and 0.43. And I got this last one over here. It's already equal to 0. And I'll just plug in down here. Opposite B plus or minus square root B squared. If you don't put parentheses there, you're going to mess that up. Be careful. Minus 4 times A times C. All over 2 times, whoops, I'm getting ahead of myself there. 2 times 4, which of course in the next step, my denominator becomes 8. Now, everything underneath that square root comes out to -15, and that should be a huge flag for you. If you got -15, you can't take the square root of a negative number. This is no solution, right? Which means if we were going to graph this, this parabola would not cross the x-axis. We've talked about that before. Okay? So you guys were pretty solid with this before we left. Just got to make sure you use your parentheses where appropriate. Don't take shortcuts, and you're going to be fine. Now here's another word problem similar to the one that we did together the other day. This equation is a little bit more involved, though. If you remember, the one that we did the other day did not have a b term. It just had a t squared. There was no t. So we solved it by using the square root method. But in this particular problem, there is a b term, and these numbers are big. You don't want to try to factor this. I mean, there is a GCF. You can take out a 2, but still, I wouldn't want to do that. But so when it comes to that, we're going to use quadratic formula. Now, part A should be simple. Remember, h is height of the ball, t is time. All we're doing is plugging in 1 for t with this first one. And just figuring out what that comes out to. Remember, this is going to end up being -16 plus 40 plus 70. And you get 94 feet. So after a second, the ball is 94 feet up in the air. It says you toss That's pretty high. But if you remember, to throw a ball 94 feet up in the air, that's really high. Looks like your starting height here was 70, so you were standing pretty high. Maybe you're on some kind of cliff or hillside. So you had something going for you there in the beginning. Just waiting for my screen to come back. It will. It usually does. Just got to give it a second. There we go. Now, when will the ball reach the ground? Okay, when it reaches the ground, of course, you know that the height is 0. So I replace the h with the 0, and I need to solve this. But here, I can't do the method we did the other day because we have a b term. I don't want to try to factor this. Even if I take out the GCF of 2, I'm going to have a leading coefficient of 8. It's just, the numbers are big, forget it. I am just going to do quadratic formula, and that's okay. So t equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. So I get negative 32 down there. I get negative 40. That number underneath the square root sign is really large, 6,080. Now I'm going to do, one with the plus, one with the minus. One of my answers should be negative 1.18. The other one is 3.69. Remember, this is seconds. We cannot go back in time, so this answer gets crossed off, and it would take the ball 3.69 seconds to hit the ground if you're throwing it at that particular angle from that height with that, initial speed. All right. So here, I want you to think before we do these problems about the methods that you might use. This is kind of a little synopsis of what we've done these past couple of days. Remember, something you want to consider is there a B term? Is there a B term for number 3? I'm hoping you're saying no. And if that's the case, you want to get the x squared by itself, take the square root of both sides, and remember, don't forget to put in the plus or minus, okay? And you get plus or minus 10, you're all set. Now here, it's only like 2 terms, but there is an a term, an x squared. There is a b term. So this is where you want to consider quadratic formula or factoring. Either, whether we use either method, we want to be equal to 0. So I'm going to move that over. So I got 15x squared plus 10x equals 0. And I'm thinking about factoring here. Take out the GCF, which is 5x. What's left inside? 3x plus 2. This is simple. Now we just write down our 2 answers. Remember, any x in the front, you get an answer of 0. And that's going to be negative 2/3 because that's what's going to, remember, that's 3x plus 2 equals 0. Move the 2 over. Do a little dividing. All right. If you just have a fixed constant in the front here, no x, then you just kind of ignore that if it was just a 5. Last one here, there's multiple terms. It's already set equal to 0. I'm thinking about trying to factor because it looks like it might be easily factorable. Boom, it was, wasn't it? We just get one answer here. Now, if it wasn't factorable, we would have gone back and tried quadratic formula, just what we spent time on earlier today. Okay, now some additional review of some newer material that we've done here during remote learning over the past couple of weeks. Remember the discriminant. The discriminant is just part of the quadratic formula. And the discriminant allows us to determine the number of solutions. Okay? The discriminant, if you recall, I hope you recall, because it's not that long ago we did this, is b squared minus 4ac. That's the part that's underneath the square root sign. So if that part comes out to be negative, there's no solution because we can't take the square root of a negative number. If that part comes out to be positive, we have two solutions because you're going to add that to something and subtract it from something. That gives you two different answers. And then lastly, if the discriminant was 0, you have one answer. So you're not actually solving here, okay? You're just doing the discriminant. Remember, the discriminant, you want to be equal to 0, but this thing in front, the f of x, g of x, or h of x, remember that's the same thing as y. We just make it 0 because, if we were to solve, x-intercepts have the y values of 0 anyway, all right? So if this was, picture a 0 there, I'm going to, my a, or my b, sorry, is negative 3. So I'm just going to plug into this, negative 3 squared minus 4 times a times c. And this comes out to, let's see, 9 minus 40, which of course is negative 31. Now that is the discriminant. Find the discriminant, did that, and state how many solutions each graph has without solving. Well, if it's negative, we actually will have no solution. Okay, so we're asked to do two things in these problems. Find the discriminant, did that, it was negative 31. That means it's no solution. Let's do it again. Here, b is negative 12. So negative 12 squared minus 4 times a times c. That comes out to 144 minus 144, which is 0. That's our discriminant. A 0 discriminant means there is one solution. And then we'll have one more here. You maybe want to do this yourself, but again, I'm just doing the same thing. I'm plugging in. There's b, square it, minus 4 times a times c. I get 100 minus 20. I get a discriminant of 80. And the actual numerical value of the discriminant is not that important. What's important is it positive, negative, or 0? This, of course, is positive. Positive means that there's two solutions. Okay? So you're not actually solving that. Almost done for today. This is recent stuff. Okay? And I know I'm going somewhat fast, but we just did this. And remember, there's a live lesson here for Thursday, last day of April, Thursday, April 30th at 1:30. A discriminant greater than 0. That means it's positive. That means there are two solutions. So that would be a parabola that would look something like this, because that would be one solution, that would be the other. Remember, the solutions are the x-intercepts. This is less than 0. That's negative. That means no solution. So you could have a parabola like that doesn't hit the x-axis. It could be like this as well. It doesn't matter. It could be like, there's an infinite number we can draw, just as long as they don't cross this x-axis at all. Now remember, this here, what I'm going to do now is incorrect. Sometimes people say, oh, what about this? But remember, this really goes on forever, and it would cross the x-axis at some point. Okay? Discriminant of 0 means one solution. That means that your parabola just comes down and nicks the x-axis. And okay, the last three problems of the day. This is what we just did last week, and I thought you guys overall as a group did a pretty good job with this. You're asked, this is in standard form, you were asked to change it to vertex form by completing the square. So if you recall, we rewrite it. We leave a little space after the b term, because that b term, I'm going to cut it in half, which gives me -3, and I'm going to square it. But I'm going to keep it balanced by subtracting 9 there at the end. And I'll do the long version on this one. By doing that, we created a perfect square trinomial. If we factor this, we would get x minus 3 times x minus 3. And these two things would be a -7 hanging off the back. And usually I just go straight to this x minus 3 squared minus 7. Now, it doesn't say this in the instructions, but if you're asked to write down the vertex, whatever x value makes this come out to 0. In this case, it's 3. And you write this number down directly. So it's the same stuff for the other one. Sorry, you don't have a lot of room here. We would rewrite x squared plus 4x, leave a little space, minus 7. Cut this in half, 2, square it 4, keep it balanced. I'm not going to show that intermediate step here. If you factor this, you get x plus 2 times x plus 2, which is x plus 2 squared. You have that minus 11. And of course, the vertex here would be -2, -11. And on this one, remember, we got to move things over. We want to be set equal to 0. So I would move this over and the 3 over. So I would get 0 equals, but 0 is kind of interchangeable with y. X squared plus 10x. I'm going to leave a little space. Minus 3 because I moved the 3 over. Now I'm going to complete the square. Cut this in half. Square it. Keep it balanced. So I get x plus 5 squared minus 28. The vertex would be -5, -28. Okay? Again, kind of quick, but live Zoom lesson on Thursday, April 30th at 1:30. So you can stop me at any time during that lesson to ask questions. See you then.